the median of ages of these 5 individuals the same numbers. First, we should sort our data. So I have sorted them 24, 28, 29, 32, 41. Okay. The median, as I told you, it is the value that is centered in the middle of your data after they are sorted. So you can look at them and you can see the median is this value 29. But how we can write it as an equation? It is the x value, okay, which rank is n plus 1 divided by 2. So what is n? It's the sample size. We have 5 uh, values, so it's 5 plus 1 divided by 2, it's 3. So it's x with the rank 3. So 1, 2, 3. You see? This is how we get the median. These measures, I don't think that you're going to work with them like calculate them by hand. I think if there's some of you guys who calculate them by hand or doing this for academic stuff, but most of us most of us guys, when we work with the data analysis, we use software, so you won't need to calculate them in these equations. Of course, we are going to work with software languages like R, but it's a really important thing that uh, you know what is going on, like when you are uh, executing the commands mean in the R language, like what is happening. It means it's really simple. uh, um, Example. But the idea that I'm talking about, to know what is happening when you are when you are running this command. Like there's an equation that is happening. The compiler is sorting the data and so on. It's really easy to think about it when you have some easy stuff to calculate them, but it's get more complicated when you are building models, for example. So that's why I think it's better to each person to work with descriptive statistics before he get to more complicated stuff. But why I have these, that's complete. Why I have these two equations? Because sometimes I have an even uh, sample size, like 6, 8, 18. Even values, guys. So for this example, I have 24, 28, and so on to 53. There are 6 values. Like, how can I get the median? So this is an even sample. I can take these two values that are in the middle and calculate the mean for them. Like for example, this example. This I'm going to use this equation when n is even. What is the median of these 6 individuals? I have sorted my data. The median is going to be the values, the mean of these two values, which have ranks of n. N. Sorry again. I'm not gonna I'm not gonna draw. Okay. uh, n divided by 2 and n divided by 2 plus 1. So we have n 6. So this is 6 divided by 2, it's 3, and this 3 plus 1, it's 4. So the median is going to be the values uh, uh, x3 and x4. So 1, I don't need that, I don't need that, I need this 3 and I need 4. You see, sum them, divide by 2, I get the 30.5. This is our median for this sample. The third measure of central tendency, it is the mode, and of course uh, we use the mode with discrete values, like you see here in this example 2789411. The mode is the most frequented value, the most value occurring. Like for example, it's really easy idea. For example, what is the mode of purchases of these 15 customers? Like the first one bought two stuff, second one 7894111, sorry 1157611421. Now, which is the most frequented value? You can count them, guys. It's going to be 1, because we have 1 2 3 4 5 ones. There's 5 ones, so the mode is going to be 1. You may have um, two modes, like when you have two values that are frequented like the same. Like for example, if you have 5 2s, so you have two modes. Measures of central tendency. We're here with the central tendency. Now we're going to talk about percents and cumulative percents. And of course, it's when you work with discrete values, like for example, this type of data, it is ordinal, for example, or let's say just nominal, like marks A, B, C, D, E. It is about to count each how many times each value occurred, and we get percent, like this value, it is for example 40% of my data. Second one is like, and so on, and we can get the cumulative percent. You can understand these ideas by just working with the example. There are really easy stuff that you can't simplify them more. Like you can get them from this example. uh, Calculate the percent accumulative percents for these students marks. I have students that are about 15 students. First one gets E, for example, in the math subject, A. Second one B, B, C, A, D, A, E, so on. Sorry. So we build this table. The marks here: A, B, C, D, E. How many A's I have? 6. And how many B's? 5. I think you guys who study statistics had worked with this table before in the early years in the university or in the high school. And for people who didn't work with these ideas, it's really easy idea. You can try it by yourself, and after all, you won't work it by hand, you will do it by software. So but is, as I told you, more than one, that is really important to think about how did we get this idea. We have 6 A's, we have 5 B's, 2 C's, 1 D, 1 D. Cumulative count, it's like counting all the values. It's not really important, but I've added this column because I want to use it like just to simplify the idea to talk about cumulative percent. Cumulative count, like I have 6 A's. In the other data here, in the other value, it is 11. Why? Because it's the number of A's and B's. It's cumulative. It's accumulating these all values uh, from top to low to bottom. So we have 6 A's, 5 B's. So we have here 11. 2 C's. So we get 13. 1 D 14. 1 E 15. You see. Now we'll talk about the percent. Like if you take 6 and divide it by 15, you'll get 0.4. If you want to read this value, not just like a probability as a percent, so multiply it by 100, so you'll get 14%. Like I'm saying, I have 14% of my students who get a mark of A in this subject. Now let's get to the other value. This cell tells me that there are 24% of my students who got B in uh, the exam of this subject, and so on. We have 30% who got C, 6.7, D, 6.7, E. If you try to sum all of them, you will get 100. You may not get really 100 because I've just rounded some values, you see. Now let's talk about the cumulative percent. uh, it's like the same idea here, the same idea. I have 40% of my students who got A. I have 74 who got A or B. I'm just summing these values. I want to see this one. Okay, so it's 14. Now it's 14 plus 34. Now it's so I got 74. Now 74 plus 13, I got 87, and so on until I get 100. That is it's a 100% that all my students got A or B or C or D. And it's of course. So let's get to the other measures, but I think guys we can stop here in this part. There's another part to go. It's going to be in the next of this video. We'll complete with the measures of variance and measures of shape. So happy learning guys. I hope you get most of this clip, and I'm waiting for you to watch the second part. So bye bye and happy learning.